Good evening, everyone. In our last videos, we had very clear discussion about graph data structure. What is mean by graph data structure? How we can able to represent this graph we have seen. In this, how to represent adjacency list, that is list of a list. So I explained very clearly. Now I want to represent this one by using matrix. Okay, adjacency adjacency matrix representation, adjacency matrix representation of a graph, sir. How we can able to represent, okay, a graph by using this adjacency matrix. Sir, you know very well how we are going to represent with the help of matrix. Suppose for any graph, if you have, we can represent that in the matrix. The only thing is nothing but how many number of vertices are there. Just you have to consider those vertices. So as size of the matrix. For example, for our better understanding purpose, I want to take a simple graph like I will start from node 0. It will be very good and even it is easy to investigate. So this is nothing but a first vertex which is having connection with 2 like this, and have a connection with 2, and it is having connection with 3, and now this one is having connection with 4, and there is an edge between 1 and 2 also. Like this we have. Of course, is it a directed or undirected graph? Means undirected graph, both possibilities are there. That is 0 comma 1 is there. At the same time 1 comma 0 also is valid edge. Suppose if you have like this, if you have a direction, then either 0 to 1 or 1 to 0, only one combination will come. I think you know well about this. I am not concentrating full-fledgedly on this. Sir, how to represent this how to represent this matrix, sir? Matrix representation, something like sir, same here. Just for example, you have to represent source and then destination, and you have to link. For example, the connection from 0 to 1 is nothing but one edge. The connection from 0 to 2 is nothing but another edge. From 0 source, if you take a 0, destination can be either 1 and 2. We got these two edges. Okay, and if you take 1, if you take the edge called 1, how you can represent 1 to 0 possibility is there. Okay, this is nothing but this one, and 1 to 2 possibility is there, and then 1 to 3 possibility is there. I think no need to take this because it is inverse. I will write that part also in the code. Maybe in the last video I have not explained about that properly. I will take now. Now, sir, what is the next one? So 2 to 0, there is a edge. So 2 to 1, there is a edge. So 2 to 3, there is an edge. This one. And all these two are already mentioned, though I am removing these two. Next, what about 3? So 3 comma 1 edge is there. So 3 comma 2 edge is there. 3 comma 2 already we have mentioned. So I am removing this. 3 comma 1 is also already. Sir, now how many edges are there? So 0 comma 1 is nothing but one edge. 0 comma 2 is nothing but another edge. 1 comma 2 is nothing but another edge. 1 comma 3 is nothing but another edge. And then 2 comma 3. Like if you represent these edges in your graph, it is sufficient. Okay. If you have an edge from 0 to 1 means 1 to 0 also edge is there. Okay. Since it is undirected graph. If it is a directed graph, then separate scenario will be there. This is nothing but how to represent in matrix. Sir, let us take a matrix. So how many vertices are there? 4 vertices are there. 0, 1, 2, 3. Sir, here also I am taking 0, 1, 2, 3. Is there any connection between 0 to 0? No. Then it is indicated as a 0. Is there any connection between 0 to 1? Yes, 0 to 1 connection is there. That is nothing but 1. Same 0 to 1 and then 1 to 0. Okay, 0 to 1 connection is there. Okay, 1 to 0 also connection we have to take. Then 0 to 2, is there any connection? Yes. Similarly, 2 to 0 also we have to take the connection. So 1 to 2, that means 0 to 3 there is no connection. 1 to 0 already mentioned, 1 to 1 0, 1 to 2, yes, connection is there. That means what? 2 to 1 also connection is there. Sir, 1 to 3, yes, connection is there. Okay. Sir, 2 to 2, there is no connection. 2 to 3, 2 to 3, yes, connection is there. Okay. Next, and after that, 3 to 0, is there any connection? 3 to 0? No. 3 to 1 already we mentioned. So 3 to 2 already we mentioned. 3 to 3, there is no connection. Like this, we can represent. Okay. Sir, please confirm if this theoretical concept is clear for you people. I will go with the programmatic implementation of this one. Can you please confirm, everyone, how we can represent this matrix representation of this particular graph? Is it clear for everyone, guys? Please respond. Right. Now I'm taking program, sir. For implementation purpose, I want to take a program. Let us see how it will. Okay. I have main method is there. I have main method is there. Now what we have to do here, I am taking a class called graph. Okay. I am defining a class called graph. Maybe I required util package like this. I'm taking in this graph. Okay. I want to take number of vertices, which is nothing but v, and we need to take a matrix, right? Adjacency matrix like this. I'm taking. Then I want to provide a constructor. Whenever you are creating graph object, you need to provide how many number of vertices are required. Then I'm creating adjacency matrix. Adj is equal to, so new integer of v and then v. Okay, just I'm creating this matrix. Beyond that, nothing. Now what we have to do, by default all the elements will be 0, right? We are not required to provide explicitly. So I will define one method saying void add directed edge. Okay, directed edge. So integer, I will take a source, I will take a destination, and then I'm going to take a cost also. Okay, generally this 0 1 is replaced with their cost, but in this example just a representation, right? That's why I'm not giving any cost here. I think this matrix is also not required for us as of now, because you know the concept, right? That's why I'm erasing this. Okay. Now, sir, how you can able to add? Very simple. You have to take adjacency matrix. Source is there. Destination is there. That value you have to provide with cost. That value we have to provide with the cost. Similarly, sir, this is for what you can say directed edge. If it is undirected edge, then what we have to do? You can call add undirected edge. I have a special method is there. So there you are going to provide a source. As usual, you are providing destination. As usual, you are providing cost. But in this, what we have to do? I am calling add directed edge by passing source comma destination comma cost. Again, I am adding one more edge, directed edge, by taking destination comma source comma and then cost. I am calling internally. Sir, why you are calling internally that one? Because you know, right? If we have an edge from 0 to 1, automatically there is a edge from 0 to 1 to 0 also. Like this we have. This is for what? Undirected graph. So whenever you are passing two values for undirected graph, both sides it will add the edge. That is the concept. If it is a directed graph, then the source whatever you have given and the destination whatever you have given is fixed. We are not required to change. So that is nothing but the concept what we have here. Okay. So how we can able to add the edge, it is very clear for you, I think so. Sir, next I want to print this matrix. We are going to use, so print graph method I want to define, where it is going to take no arguments and it has to print this particular matrix, sir. But I don't want to print in the normal style. Okay, in our graph format I will take I is equal to 0, I less than number of vertices I plus plus. Then what we have to do, sir, system dot out dot println of, I think better print of. Sir, here I am writing vertex. Okay, vertex I is connected to. Vertex I is connected to. Sir, to which node it is connected? Sir, to which node it is connected? I think you can provide that with the help of a loop. I will write a loop. So what is that loop? For integer j is equal to 0, j less than number of vertices, j plus plus. Sir, if adjacency matrix is there, right? In that I am taking ij value. If it is not equal to 0, if it is not equal to 0, then I am printing system.out.print of. First I will print open brackets followed by j value, okay, and then comma separated by space plus a of no a adj adjacency matrix of ij I am printing. So followed by plus closing parenthesis. Like this I want to take, sir. That means, so from vertex 0, which edges are connected? These points will come. Sir, for 0, which points are connected? Have you observed? 0, comma 1 is there, 0, comma 2 is there. For vertex 1, which nodes are connected? 1, 2, 1, 3. From vertex 2, which nodes are connected? 2, 3, only 2, 3, I think so. From vertex 4, which nodes are connected? Vertex 3. So like that, it is going to display the list. But let me see whether we are getting the proper output or not. After printing every row, we know very well, since it is a matrix style, I want to print an empty line. That's all. Sir, I created a graph class. In that class, whatever data you required, I have given. And I defined two methods. One is used to add directed graph edges. Another one is to add undirected graph edges. Both are same. And one method is there for print graph. Now, how to define the graph? Already graph class is there. Just create one object for that graph class. Yes, my object is there. Then what we have to do? Sir, g dot add edge. Directed edge or indirected? Let me take undirected edge. Sir, from which 0, comma 1? Let us assume cost is 1. G dot add undirected edge of 0 to 2 connection is also there. So this is from what? From vertex 0. From vertex 0. So same thing I want to take from vertex 1. Which nodes are connected? So which nodes are connected? 1, comma 2, comma cost is always 1. So g dot add undirected edge of 1, comma 3, comma 1. Then so from vertex, okay, from vertex 2. From 2, which nodes are connected? G dot add undirected edge of 2, comma 3, comma 1. Sufficient, right? So from 3, we are not required to add, because from 3, which nodes are connected? 1 and then 2. 3, comma 1. Already 1, comma 3 is there. Since it is undirected, it will add both 1, comma 3 as well as 3, comma 1. Both it will be added. Okay. Next and after that, so 3, comma 1. 3, comma 2 is also there, right? But already 2, comma 3 we have mentioned. That's why it will. And one student is sending, we have to pass number of vertices in the graph constructor. Is it? Yeah, number of vertices we have to pass. Here, 0, 1, 0, 1, 2, 3. Total 4 vertices are there. We have to pass that. That's all, sir. Now we have to print the graph or not? Yes, I am taking g dot print graph. Okay. Now we will execute this code and we will check really that a graph got created or not, so that you people will get a full-fledged clarity. Java C, I am taking test.java. Sir, is the code compiled fine? Perfectly. Java space test. I think for this example, you got a clear clarity, sir. Have you observed here? Sir, vertex 0 is connected to, okay, vertex 0 is connected to 1, comma 1. 1 is nothing but what I can say, you can ignore these values because these are representing the weights. Okay. So vertex 0 is connected. Vertex 0 is connected to 1 and then 2. Is it correct? 1 and then 2. Vertex 1 is connected to, vertex 1 is connected to 0 to 3. 0 to 3. Okay. Vertex 2 is connected to, sir, 0, 1, 3, right? 0, 1, 3. So vertex 3 is connected to 1 and then 2. Like this we have. Okay. This is the way how we can able to represent. Okay, so this graph data structure by using this adjacency matrix representation. Even in the adjacency list also, I have taken some code. Of course, I will change that code because these functionalities are not there, right? That's why I'm trying to add that code. Don't worry, I will insert. Can you please confirm? Is it clear up to this, friends? I request everyone to please confirm. Clear up to this? Can we do it without passing cast? Yeah, we can do that. We can do that, Swapnil. Without cast also you can do. No problem. I think here we have passed cast. No, I think so. No. Let me check. Yeah, we have passed cast here. Without passing cast means what? You have to define the same method without taking cast. So by default, what will be the cast? By default, cast will be 0 or 1, like that we can take. Okay. Yeah, that we can write manually. I think in the matrix representation, we don't have that much importance. Anyway, we won't use at all. So in the next example, I will show. Sir, previously adjacency list representation I have taken, right? But I need to do some small modification in that. So I will try to create one more program. Okay. So what is that program is nothing but adjacency list representation. I want to represent this in adjacency list. Let us see how it will be. Sir, same program I am taking, no modification at all. Graph, internally this graph is contains some static class. Okay, static class, you know very well. In the last videos, we covered very clearly edge class. In this edge, which data we have to take? Destination is required. Source is also required, but I am not going to provide here. Okay, so like this I am taking, and whenever we are calling, we will pass a destination and then cost. So current node destination will become, so current vertex destination will become the destination whatever you have given, at the same time even cost also. Then we are indicating the number of vertices, and this one is not a matrix, right? So what we have to do, I am creating one linked list, array linked list. Within this again I am taking one more linked list, which is going to take edges. Sir, it is a nested linked list. Already one linked list I am creating. This is my linked list. In this linked list, some links will be there, right? Next node, like that. So every node is again connected to one more linked list. Like this I am representing. Okay. So main linked list is there. Inside that, every node is again a linked list, which is going to hold the type as edge. Edge means what? Destination will be there and cost will be there. Now, sir, what about this linked list? We have to create, right? So at the time of creating the graph, we are going to create this particular linked list. How to create? Already we have adjacency is equal to, so new linked list of edge, like this I am taking. So I'm creating a main linked list, not nested. Main linked list I created. Again, we have to create nested list also, right? How many nested list you have to create until the number of vertices? How to create adjacency list dot add of? I'm going to add new linked list, which is going to capable of storing these edges. That's all, sir. So the main list is there, right? In this, I'm going to add one linked list which can hold edge type of elements. Like that, how many vertices are there? Those many new links will be there. So this is nothing but a constructor of the graph and a edge class. How you can able to define? Better to declare this one as also static. Okay. So I think this new structure of graph class and edge method, how we can able to take, these two are clear for you people, I think so, right? Can you please confirm, guys? Clear up to this? Friends, please confirm, everyone clear up to this? Any particular reason for using linked list over array list or does not matter? No, no, no. You can use anything. For my convenient purpose, I am taking. That's all. Right. Now, sir, how to add these objects? How you can able to add these objects? Okay. So how to add edges? Add directed edge. I'm taking integer source, destination, and then cast. 1 second. So I'm taking source, destination, and then cast. So what is the first step? How to add this? We need to create a new edge. So edge is equal to, okay, I'm creating a new edge by providing only destination and then cast, because at the time of creating a new edge, we are providing only destination and then cast. Sir, why you are not taking source? Because so in the linked list, 0th link, that is the first link, is always pointing to the first node. Second link is always pointing to the second node. That's why. So even you can use a small loop. That's why I'm not writing. But destination may be varied. That's why. Sir, like this, I'm going to create a new edge. How to add this edge? Sir, adjacency, main list is there. Dot get off. Sir, I'm going to take a source. Already we have passed source, right? Dot add off. I'm going to add this edge. That's all, sir. Sir, how it is going to add? Already we have a new list is there. A new linked list is there in this style. In this style. Okay. So here assume 0, 1, 2, 3, 4, like this we have. Suppose consider my graph is nothing but 0. Okay. Connected with 1. So connected with 2. Okay. So connected with 3 and then connected with 4. Like this I have. Consider. Like this I have. Okay. Sir, now what I'm doing? Add edge of. How to add this edge? For example, consider I want to add this. How we are going to add 0, comma 1, right? 0 is nothing but a source. 1 is nothing but a destination. Ignore the cost. Anything you can provide. Sir, here source will become 1. Destination will become 1. Sorry, source is 0. Destination is 1. Edge. I'm creating a new edge with this destination, and then cost is nothing but consider 1. Okay. So this is nothing but an edge which we got created. I am adding this edge where in which position we have to add. Sir, get off source. What is the source value? 0. Adjacency list dot get off 0 means pointer will be there here. So for this, I want to add one node, one edge, which is nothing but having 1, comma 1. Now, sir, next time I am going to add this edge. How you can able to add 0, comma 4, right? 0, comma 4. Sir, here source will be 0, destination is 4, and then 1. Sir, now again source is 0, right? Add edge. Where it will be added? For this continuation. So the nodes which are connected with 0, those will be added here. The nodes which are connected with 1. Sir, which nodes are connected? So 0, comma 1. Okay. So next and after that 0, comma 0, comma 1. 0 is the destination, and another destination will become 2. Another destination will become 3. Like this we have. For 2, which nodes are connected? So first destination is 1. Second destination is nothing but 3. Third destination is nothing but 4. For 3, which nodes are connected? Sir, first destination is nothing but 2, 1. Second destination is nothing but 2. Third destination is nothing but 4. For 4, which nodes are connected? First destination is 0. Second destination is 2. Third destination is 3. Next destination is 4. Like that, these edges are going to be added, sir. Like this, these edges are going to be added. Sir, can we write the same thing? Can we write the same thing for undirected? Yes, I am providing source and I am providing destination and then I am providing cast. Okay. Sir, what will happen? What will happen whenever we are going to call this internally we have to call add directed edge for 4023 for 4023. Yeah, 4 is not there. Yeah. So add directed edge of source comma destination comma cast, and then you have to change this. Okay, right. Sir, if I am not providing cast, then what will happen? Since method overloading is there, right? So I'm going to ignore the cost. If you are not providing cost, then I will pass one, sir. If I'm not providing cost, I am providing one. Have you observed? Like this, we can change. Since this is the overloaded methods, we can call, no issues at all. With the same name, you can define any number of methods, no problem at all. Like this we have. Okay. Do you know, at 8 o'clock evening today, I'm going to start a Python with data structures with Python. So in that, definitely, I need to concentrate on OOPS concepts mainly. But there, unfortunately, my Python is not providing any support for method overloading. Okay. That means these kind of facilities we don't have. So what alternative we have to do there, that we are going to see there. Okay, how it will be. Chapters are same. Yeah. Data structures with Python, I'm going to start. Within 15 minutes, it will be started. The interested candidates, you can attend the demo, no issues. Sir, like this, I'm going to add. Sir, can you please confirm? 1 minute. Let me take this one also. Printing of this. Is there any change here? Print graph I'm taking. I is equal to 0, I less than number of vertices. But I think here we have to create a linked list. Linked list which is holding edges. I'm going to create one temporary linked list where adjacency list dot get of I. When we are running I is equal to 0, 0th list we are going to get. But in this, we need to see what are the vertices connected, right? Vertex 0 is connected to. Okay, so I think this loop is not required for each edge E present in that temp, because in the temp linked list, we have only edges, right? For each edge in this temporary linked list, I am going to print that one. Sir, how you can able to print that? System dot out dot println of. Okay, sir, here E is there, right? E is there, right? So it's a destination I want to print. It's a destination I want to print. And here I want to print its a cost. So E dot, I want to print a cost. That's all. That's all. Sufficient. Now let us check for the previous graph. Is it going to work or not? Let me cross check. Okay. So we have previous output is there. Now you can able to see same output we are getting or not. Yes, the same output we are getting. Okay. Yes, there is a change. There is a change. Sir, if you want, I will do one thing. I will do one thing. So here, just for your understanding purpose, I'm taking arrow mark here. Okay. Just to see the changes. Have you observed? Whatever output previously we got, same output is there for list also. This is the way how we can able to represent adjacency list representation for the given graph, sir. Okay, I think the representation of this graph by using adjacency matrix and adjacency list, full-fledged clarity you people got, right? Can you please confirm, do you have any doubts up to this? I request everyone to please confirm. Any doubts? I request everyone to please respond. Clear? What is the use of source in that example? See, source is important. Of course, here, based on this source is only it is adding, man. Why you are getting confusion? Here you can see. At the time of adding, we are passing source, destination, and then this particular what you can call wait. Okay, add undirected edge. That message is there, right? We are passing source, destination, and then cost. We are passing source, destination, cost. So it will be there source, destination, and then cost. But my edge is created only with the destination and then cost. But where this edge has to be added, in which location? Suppose if you have 4 vertices are there, 4 nodes are there, means to which node it has to connect. Have you observed here? adjacency list dot get source. If your source is 1, that list will be activated. In that I am going to add. Got it, Rohit? Clear? Cost you can ignore, man. In our next upcoming classes, you are going to get full-fledgedly information about this cost. So cost always represent how much amount it is going to take to move from that particular position to next node. What is the edge cost? So as of now, we are not concentrating about the cost. Yes, of course, it is the weight. As of now, we are not concentrating on that. Okay. Yeah. Right. Sir, next one. Next one. Sir, traversing. Traversal of graph traversal. Graph traversal. Can you please confirm what is mean by this graph traversal? Visiting every node present in the graph. Visiting every vertex. Okay. So is called as graph traversal, sir. Graph traversal. In tree data structure, we have pre-order, post-order, in-order. Okay. So level order like that we have. But in the graph, we have only two concepts are there. Can you please tell me? Very good. One is nothing but depth first search, DFS, and breadth first search, BFS. Like this, we have two algorithms are there. Okay. Like this, we have two algorithms are there. Of course, we are going to see in detail about these algorithms. Don't worry at all. But just for our understanding purpose, I want to take a simple example program to demonstrate this BFS and DFS. Consider, sir, I have some nodes are there like this. Okay, I have some nodes are there like this. Consider this is nothing but one node. Okay, example one I am taking, sir. This is nothing but another node. 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 Like this we have. Sir, I need to give labels for this. So from our basic definition, consider this is 0th node. This is nothing but a first node. This is nothing but a fourth node. This is nothing but a second node. This is nothing but a third node, just for our understanding purpose. And is there any direction? No. Is there any direction here also? No. Is there any direction here? No. Is there any direction here? No. Is there any direction here? Sir, how you can able to add these edges? Here itself I am providing. Okay, how you can able to add the edges? Here itself I am providing. Sir, how you can able to add the nodes which are connected to 0? How you can able to add 0 comma 1 comma 1? Consider weight is 1. I'm ignoring the weight. Next, so is there any node connected to the 0? No. Next, the nodes which are connected to the 1. Sir, which nodes are connected to the 1? So 1 comma 0. Okay, 1 comma 0. And then the nodes which are connected with 1 is nothing but 2. And then 1 comma 4. Like this we have. And the nodes which are connected to 2. So we have 2 comma 1 is there. And we have 2 comma 3 is there. Like this we have. And the nodes which are connected to 3. Sir, which nodes are connected? You can take 3 comma 2 and then you can take 3 comma 4 like this. Sir, the nodes which are connected to the 4, I think we can say 4 comma 1 and then we can say 4 comma 3. These are the nodes which are connected. Of course, in the program, I will explain how we can able to add these values. How we can able to add these values, I will take, sir. Okay. Now, I want to see BFS and DFS of these, sir. Okay, so I want to see BFS and then DFS. Sir, first I will explain, okay, BFS. What we have to do in this BFS, breadth first search. BFS. Now listen carefully how I am going to draw this. So the first step what we have to do here is, sir, first first we have to start from the source. I want to take my source as a 0. We are going to start from 0. We are going to start from 0. Now print this 0. We have to maintain one queue internally, same like level order traversal. Okay, sir, what we have to do? First, we have to push this 0, and we have to add the nodes which are connected to this. Which are connected to this only one, right? So add one. Okay, so this one got removed and printed. Next, the node which we have is nothing but we have to maintain one boolean variable, boolean so array with visited. Okay, so 0th node, first node, second node. Okay, so third node, and then fourth node. Like this we have to take. Okay, sir, anyway, I have demo is there. I will close this, and we will continue tomorrow. Even implementation of this BFS DFS I will continue tomorrow, sir. Sir, maximum this week I am planning to wind up the course. Maximum by Sunday I will wind up. Okay, this weekend we have classes. So Sunday I'm going to take red black trees and then AVL trees. Sunday 3 hours I'm going to take. The people who are already attended AVL trees, you can ignore for first 1 hour. So 1 hour I will take AVL trees, and then 1 hour I will take red black trees. Okay, maybe half an hour like that. So Sunday we are going to finish that red black trees and then AVL trees. Okay, and this week completely graph we are going to concentrate. After that, greedy method and dynamic programming we will finish, and then divide and conquer. Divide and conquer matter of 2 or 3 minutes class. That's all. Okay. Next, and after that, time and space complexity, 2 days I will explain. With that I will close. Okay. Yeah, priority queues also is there, right? Yeah, I will look into that. I forgot to add that. Yeah. Maximum I will try to wind up by this week, sir. Okay. Right. So thank you. We will see for tomorrow, sir. Asymptotic notations will comes under time complexity. Yeah, thank you, sir.